x is irrational, then x plus 1 is irrational.
Okay, so
Okay.
we're gonna start the theorem, right?
Yeah, the thing was to make the negative statement positive, so you know it will not be messy. So in this theorem it says if x is irrational, then x plus 1 is irrational.
Thank you.
So in other words, we can say that if x plus 1 is rational, then x is irrational.
Yeah.
So yeah, so in this example, let's suppose that x plus 1 is rational. So let's say that x plus 1 is rational. How can you represent the rational number? Let's say a and b. It's gonna be a over b.
Let a and b.
Okay, like first, let x plus 1 is equals to rational.
Real numbers.
Yeah.
Numbers. Okay. So to be rational, a rational number is a fraction, kind of.
Yeah.
So I said let a and b be real numbers because they need to be real numbers for them to be rational.
Yeah.
So the rational form is a out of b, right? Yeah. So okay.
So yeah. So it says that let x plus 1 be rational.
Yeah.
Right? So x plus 1 is equals to a over b. Right?
Yeah.
Rational. Any rational. So let's find x now. Because the question is if x is rational, then x plus 1
is rational.
So let's try to keep the x separately. So x is equals to a over b minus 1. So it's going to be x is equals to a minus b over b. Over b. Yep. So from here you can conclude that this is rational number. Where a b cannot be equal to 0.
Yeah. B different from 0. Okay.
Yeah. This is the first question, which will prove that if x is rational, then x plus 1 will be rational.
Yeah.
From here we can say that if x is irrational, x plus 1 is irrational.
Yeah, we'll have to do it the same way.
Yeah, the same way. So we'll say that then x plus 1 is irrational if x is irrational. Put it in the previous statement. Okay.
Partial control positive.
Okay.
I think we need to start with the first one before that. Yeah. The
Suppose that we have a statement
form P
and Q.
Can we take some of the chips?
R.
Can we take some of the chips? Of course.
You could do that.
and we want to use an indirect argument, right? So we could prove that negative r equals to kind of.
We could prove it this way.
But how do we prove negative
p plus q, not q?
Not or and okay. And we have to use elimination. That is to prove minus b. P. And then vice versa.
Yeah.
Oh, now you eat. Now you eat, huh?
No, I thought it was yours. I didn't want to. No.
Oh my God.
I was doing the code. It didn't work. Oh, did it work?
Okay. Thus, in effect, we are using, we are supposing P and not R and providing not Q. The truth table will show that. Okay, this one
we need to do it with the truth table or what? Because I don't really get I get this explanation, but or vice versa. They said we have to eliminate my P by assuming that by assuming not Q.
Okay, if you get this, the theorem finished over here. So the proof is over here now. This is thus in effect we are supposing the P and okay, let me
I
try
think
to see
alright.
something.
Yep. Do you have a?
Or so it's gonna be
When we do in effect, we are supposing P, not R, proving not Q.
okay, so it's gonna be not P. So we're trying to make it
Oh,
reverse.
okay. Okay. Look,
Q.
for example, we have P and Q equals to R. Okay. So they say we need to find not Q. So not Q will be, so to be able to find not Q will be P and P and not R equals to not Q. Okay. So
I know how he got this one.
which one?
How he got this thing.
How did you get it?
We call P and let me just first understand why he did this. We call P and not R implies not Q. Instead of P and Q implies. Okay, he just did the. Okay, the different version of writing this one is P. Okay, let me write it again. P and Q implies R, right?
Mhm.
We can write this statement, like this whole statement, as P implies Q is the same thing as not P or Q. Okay?
Yeah.
So this is P, this whole thing is P, this whole thing is R. So it's gonna be not P or not Q or R.
Okay.
Did you get it? This whole thing is P, this thing is Q. Not P or not Q when you put this one and the sign changes. Or R. So we shuffle it to make it not P because it's or, so we can change any position. All of them are or, that's why we can change it. Or R or not Q. This one is the same thing as here, but we just make it reverse. Reverse is not, we put not here, not P or R implies not Q. See, the Q will stay the same in both ways. Here will be not. We put not here. It's gonna be P and not R implies Q. Not Q, sorry. P and not R implies not Q. But I don't know why we did this.
I mean, actually, this, and this is equal to this. So
Yeah, they're all equal.
yeah, I just wrote it back. It's like,
He wrote it in different format for some reason.
no, what different from?
Like this is the first format, let's say, this is the second format. They're both equal, logically.
Yeah. Now, what do you mean by this? By this, and this is the same?
Yeah. But no, this is our original question.
Yes.
He wrote it in
This
this
is what
way.
we found right now. This is what we
Yeah.
is equals to this. This is what we found.
Yeah.
Now this is equal to this.
Yeah.
So yeah. So he just wrote it. He's like, we call P actually what we found is called the partial contrapositive of the initial one. That's what he wrote. I don't know if you understand.
Yeah, I got
This,
it, I got it.
we found this, right? So this is this. So he said we call the result that we found the partial contrapositive of the initial value. That's it. Like he just resumed it into a sentence.
Okay. Yep, so far.
But what I see is that to be able to get this, you have to remember you remember the last
logic, the
one.
first ones, yeah. Okay. Another question.
Theorem,
The
yeah.
theorem is if
Let's
x and y be element of real numbers, If x is rational and y is irrational, then x plus y is irrational. Okay, so it means if x is rational and y is irrational, then x plus y is irrational. So we can write that if x is rational and y is irrational, then x plus y is irrational.
Let x and if x is rational and y irrational, then x plus y is irrational.
If x is rational
And y irrational, then x plus y is irrational. So that means that the irrationality takes over the rational numbers.
Yeah.
That's the same. Like, look from here, we know that this is rational. Why? Right? The minus one is rational, and the a out of b is irrational. Right? The sum gives irrational number. We have a proof.
Oh. No. This is different thing. It says that if x is rational and y is irrational.
Yes.
If x
Let's consider this as x and this as y.
over b, okay.
Let's consider this as x and this as y. So if x is anyway, let's consider a out of b, y, and minus 1
Yeah,
x.
actually.
So yeah, x plus y is irrational though. Because to be able to do the summation, you have to find the common denominator and then do
Okay.
it, and then you'll get a
Let
rational
me
number.
assume. Let's say x is rational, right? 3 over 2.
Yeah,
Y is
Irrational.
irrational. Plus,
1.
let's say 1. Our result will be 5 over 2.
That's what I said.
Our result is rational.
No. Oh yeah.
Yeah. Our
No,
result.
wait.
It says that there is some. So this is the tricky part. This when we have to start working
This
the
is a
formula.
wait. This is a rational square root and irrational rational number. Square root.
It's a good question.
Wait, let me figure it out.
You see it? Okay.
Um,
Rational, okay. X and x was rational.
okay, a square root rational number. Square root number. Let's see. Are square roots numbers rational? Yeah, that's the thing we need to know. They say in general, not usually. That means that there are some and yeah.
Yeah.
So let me read what they say. They say the square root of an irrational number is always irrational. Oh, okay. So the square root of an irrational number is usually irrational, but not always.
Okay, this is tricky. It's tricky.
No, I mean, and they say, you can tell by this test. Okay, if both of the numbers and denominators of the
Let me see that is x is rational and y is irrational, then x plus y.
Oh, okay.
Okay,
So,
if let's say a like x and y, x and not y, then not z. Let's say this is the question. Which we made it. It's gonna be not x or y or not z, which we put here, not x or not z or y, which we will did this x and z, then y. So x means rational. Y means irrational. Okay. y means irrational, and z means irrational. X plus y. So in this equation, the same method that we did here, we found that x. So let's say if x is rational, we translate it now in human language, and x plus y is now, see, it was irrational, not rational. Now it became rational.
Let's start from the beginning.
Okay.
Let's start from the beginning. Okay. We have two numbers, letters.
Okay.
X, Y.
And okay,
X and Y not rational, right?
no, x is rational.
Yeah. Y.
Y is not
rational.
rational.
Okay.
Z is also not
No, rational.
rational.
Okay.
See,
Yeah.
irrational, not
Mhm.
rational. And we made the same thing as here. We try to make it the implementation. We try to take the implementation off.
Okay. No. Okay. Okay.
We got through this process, right?
Mm-hmm.
The result is x and z. So rational and rational, then rational.
Okay.
So it means if x is rational and z
Okay,
is
it's
rational, then y will
is
be rational. This is the
Yeah. this-
reverse of
okay.
it.
Mhm.
The reverse of this question.
Okay. So if X is rational and Y is not rational, then okay.
Here it says, suppose that x and x plus y are rational.
Suppose that X.
Rational.
okay.
Then y will be rational. There exists a, b, c, d element of z. Because we took a, b,
Yes,
c, d to
yeah.
rational, you know, a over b.
Mhm.
So let's say x is equals to a over b.
And Y.
X plus y
Okay.
is equals to c
C
over d. Here we try to prove that, here, see implementation. Here we try to prove that y is rational if this
Okay.
both are rational. So x plus y is equals to c over d. He did. Suppose that x and x are over, then there is exist a, b, c, d in the element of z such that x is equals to yes, then y is equals to here. Okay. 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 Now I try to understand this part. Let's say x plus y. Y is equals to minus x. I remember how
Did I get it?
I remember how he explained
Look,
this part.
Look, this part. Look. X plus Y equals to X plus Y, right? So Y equals to X plus Y minus X. This is exact. X plus Y equals to X plus Y. So Y equals to X plus Y minus X. That's why. Because if you want to find Y, you have to minus X from
Yeah,
Y.
but why did you write it in this format?
In which format? In this one?
Yeah, x plus y is equals to.
Okay, X plus Y, what is it equal to? I mean, there are two kind of explanations that you can get, two kind of ways to get it. X plus Y equals to X plus Y, like 1 equals to 1. That's already a fact, like that's known. We didn't change anything. But you could do it like this too. To be able to get Y from X plus Y, you need to minus X. You need to get
Yeah.
X away. So that's also a way to explain it. You have two ways of that.
Okay.
But that's kind of for someone who understands the logic behind this one.
Okay, then we have it already here, x plus y.
Right, yeah.
And we have it already.
Because we have X plus Y and we have X.
Okay.
So yeah, we just like this formula,
Yeah.
X plus Y minus X.
Yeah,
So
then,
that
then
will be,
we,
yeah,
we
we find
subtract
this,
it,
and then we
see that
run
it's
it to the
rational.
same, yeah.
See that it's rational.
That is, yeah.
Yeah,
that
this is rational.
yeah.
So the reverse of it means like we prove that the like this equation x and not y implies not z. It means if x is rational and y is irrational, then x plus y is irrational.
Mhm.
It's the same thing we can say x and z implies y. It's all the same logic.
Okay.
If x is rational and x plus y is rational, then y should be rational.
Yeah.
So if we prove this statement, it means this statement is also true.
Makes sense.
Yep, here we did this one, he explained it a little bit. Let me see. N divided n n divides b and n divides c, and but n doesn't divide e. Okay, now yeah. I said that suppose that if n divides a,
But A, B, C, D,
it will be
E,
a is equals to n times.
if
Okay.
N divides B, N divides C, N divides D, but N divides
times
then A, N, but N does not divide E. Okay, then N divides A, B, C, D, E. I don't really get the logic behind this one. Does it say
Behind this
A,
one, I
B, C,
didn't
D,
really also get it.
A, B, C, D, E, and N belongs to Z? If N divides A, B, C, D, E, but not N, but no, A, B, C, D, but N does not divide E, then N divides A, B, C, D, E.
Does not divide.
I mean, N is divisible by A, B, C, no, N is divisible by A plus B plus C plus D plus E.
Yeah. Here's the theorem that he wrote. The partial controversy if n divides a and n divides b and n divides c and n divides d and n divides a plus b plus c plus d, then n divides e. Yeah. This is true. I got you. I got the point. Let me protest. I'm gonna write it in this format. If a, b, c, d, and let's say it's all and. Let me try to get the logic by this. Then not so it's gonna be partial controversy. If you look logically, it says that if n divides a, b, c, d, but not e, then n doesn't divide a plus b plus c plus d plus e. So we can also say that if n divides all of them,
Yeah.
it means n will divide also a plus b plus c plus d plus e.
No, that I get it, but then N is divisible by E.
Yeah.
Because here, when you go up, can you scroll up? Here they said N is divisible by A, B, C, D, but not E, right?
Yeah.
And then
A is not divisible.
No, yeah, they said then N is divisible by A
Not
plus
divisible.
B. Oh, okay. Now I didn't see the not divisible.
It's
Yeah,
not
then
Now
there
it
is no
makes-
trouble.
Yeah.
Then there is no trouble.
So it means if you can disregard this part.
Yeah.
Just disregard this part. Let's say if n doesn't divide e, then n doesn't divide, let's say,
E plus R.
yeah, e plus r. Then the reverse of e. If n divides e,
Then
then n
E
divides.
E plus R.
Yeah. And by this all the formulas, I did this. He wrote it in this format. N divides a, and n divides this one. So we're proving that n divides e. If you prove that n divides e, then we'll prove that n divides
Yeah, he
this
did
thing.
it by the prime numbers. Okay.
Yeah. So he did this thing. If you remember it, I
The
think
prime
he-
numbers.
Yeah.
You have the prime numbers that are numbers too, but they are different from the initial ones. A is different from A prime.
Yeah.
We used to use it when it was geometry.
Yeah. And all these things. I remember we did it in the class. So therefore n divides e.
Yeah, that's what I was saying.
The proof by contradiction, I don't think we came too much in this one. See, lemma, we didn't really. History, then B. Did we pass this one?
No, I don't think we did lemma.
Oh, it's yeah, contradiction. He said if there's a contradiction, then your statement, there is something wrong with your statement. That's what he said. We touched upon it, but we didn't really do a lot of it. No, we didn't do a lot of exercises here. Yeah, we did actually these exercises, but yeah, we did it. You wanna go over it?
Why not? Let's do it.
Okay, this question from this one.
I don't really remember this part. Did we do this?
We touched upon it, but it was towards the end of the class, and I was processing what we just passed in a few minutes ago. You know, he did too much today. I think he did too much last class. I think he did too much in last class. Yeah, we did too much last class because we learned too many things, and I didn't really catch it up everything. We have to do some problems. Okay, then we spend the night doing problems,
Problems,
and
yeah.
maybe tomorrow morning we'll just also share.
What about Tahir?
Tahir, I texted him. Did he reply? Can I see the phone?
I can cut it, right?
Yeah, you can cut it if you want it.
What do you mean if you want?
If you don't, it's okay, bro. I mean, I don't think so. He